Alright, hi, welcome. Today we will be doing 1.11 to 1.12 AP Calc review. This is basically what applies to my class and what we've been doing, but again, I'll try to give you the big gist of it. Let's get started. The graph of the rational function f of x is shown at the right. Write an equation in factored form for f of x. Explain how you know. Okay, so we know our equations always start with the equation like starter, which in this case would be like f of x. And basically, we can see that there's a vertical asymptote at x equals positive 2. Okay, so we know that'll be in our denominator. And then we can see that there's a horizontal asymptote at y equals 1, which means our biggest leading coefficients or exponents on top of the x's have to be the same, or like to the same power. Okay, and then we can see that there is a 0 at negative 3, and there's a whole at 4. So that means there's a common numerator and denominator. So in this case, we begin our equation with f of x. We know there's a 0 at negative 3, so it's x plus 3. And then our common factors, so x minus 4, and x minus 4 at the bottom. And then x minus 4 at the bottom, and then x minus 2 for our positive 2 asymptote, vertical asymptote. And this cancels. This is x squared, and then this is x squared, which gives us y equals 1. And that's how we know this is right. And then when it comes to our whole, if we cross these out, we are left with x plus 3 over x minus 2 equals f of x. And then if we plug in the positive 4, we get 7 over 2. And we can see that that is around 7 over 2. Because 7 over 2 is equal to 3 and 1/2. And we are right below the 4. So that is about 3.5. Our actual equation would be, okay, moving on. Okay, consider the two functions below. Write an equation in factored form and find any values of x where the graph of the function would have a whole, a vertical asymptote, or a horizontal asymptote. Okay, for this equation, write in factored form. Okay, we know an x comes out, and we're left with x squared plus 2. And then at the bottom, we have x squared x minus 3. And then our x's cancel, and we're left with f of x equals x squared plus 2 over x minus 3. Now we move on to find our wholes. This equation has no wholes whatsoever, okay? Because nothing cancels out, so there is no wholes. In this case, they don't exist. Moving on, the horizontal asymptote would be 1 because x2 over x2 is equal to 1, or y equals 1. And then, according to our factored form, if we were doing it based off this one, it would be x3 over x3, but it would still equal 1. Okay? And then we have a vertical asymptote at x equals positive 3, and we also have a vertical asymptote at x equals 0 because of this x right here. Okay, moving on. Okay, so our next equation is g of x equals x plus 3 squared times x minus 2 over x plus 3 times x plus 1. Okay, we know x plus 3 cancels out and it's a whole because the square on top is greater than the one on the bottom, or the power on the top is greater than the one on the bottom. And then we know this is going to become a 0, and this is a vertical asymptote. Okay, and then since that cancels out, our factored form then becomes x plus 3, x minus 2 over x plus 1. And then our factors are larger in the numerator, which we stated in the beginning. And then that gives us a whole at -3. And then we have a vertical asymptote at x equals -1. And then there is a 0 at +2. Okay, in this example, it's saying the domain of the function y equals f of x is -6 less than or equal to x less than or equal to 8. And the range of f is -3 less than or equal to y less than or equal to 7. Whereas to find the domain and range of h, where h of x equals the function of x plus 1 times 2 minus 3. Okay, so let's solve. We can apply a rule here, and that's the way I'm going to show you it. So basically, this rule will apply to the x. We know it will go left, and it'll be a horizontal translation, left 1. So our x we have to subtract 1, and that's it for that. And then there's a vertical dilation of 2, which means either stretch or shrink. And then last but not least, we have a vertical translation down 3. So for our y, we have to multiply y by 2 and then subtract 3. Okay, so now we can get going. Let's start with the domain. The domain of our function h of x would become -6 minus 1, which is -7, less than or equal to x less than or equal to, and then 8 minus 1 is 7. So that is our new domain. Notice we only used x minus 1 because domain is based off our x's. Now we move on to our range. Our range for h of x would be -3 times 2, which gives us -6, and 7 times 2, which gives us 14. And then we have to subtract 3, which gives us -9 less than or equal to y less than or equal to -3 plus 14, which is 11. And this is our new range for h of x. And that is our answer for that one. Okay, moving on. For each of the table values below, lie on the graph of a continuous function f of x. State the transformations that occur on the coordinates of f of x to obtain new set of ordered pairs on the transformed function. Okay, again, we will make a rule based off our transformations. So for x, we know we're going to be subtracting 3. Okay, and then for the y, we can see that we're being reflected over the x-axis, and we're also going down 4. So we need to multiply y by -1 and then subtract 4. We can explain this by saying there's a reflection over x-axis. There is a horizontal translation to the left 3. and then there is a vertical translation down 4. So we're going to plug in -3 for x. -3 minus 3 is -6. -1 minus 3 is -4. 1 minus 3 is -2. 2 minus 3 is -1. And then 4 minus 3 is 1. Okay, moving on. 5 times -1 is -5 minus 4 is -9. 3 times -1 is -3 minus 4 is -7. 0 times the negative is 0 minus 4 is -4. And then -2 times a -1 is +2 minus 4 gives us -2. And then 1 times -1 minus 4 gives us -5. So our new ordered pairs are 1, -5, -1, -2, -2, -4, -4, -7, and -6, -9. Okay, moving on. Okay, so for this problem, we need to write the descriptions for each transformation. So in this one, it states, let k be a function that is a transformation of the function f such that k of x equals 4 minus f of x with a negative x inside of it. State the transformation of the function f that results with the function g. What we can see here is that this is written funky. We know that we can put the 4 over here, and then that equation will change drastically. So k of x actually equals negative f with the negative x inside of it plus 4. So now we can write our transformations. We know there is a reflection because of the negative in front of our function f of x. Reflection. In this case, it's over the x-axis. However, there is also a reflection over the y-axis because of the negative in front of the x inside of the function right here. And then we also have a vertical dilation up 4. And that's it for this problem. Okay, moving on. Write the function that is finally graphed after the following transformations are applied in the order listed to the designated parent function. Okay, so I only picked 25 because I was not about to do all that. So 25 is y equals 1 over x 3 over x to the third power. Okay, so 1. Horizontal translation of 5, which means it will be y equals 1 over x minus 5 to the third power. Okay, this is for 1. Now for 2, reflect about the x-axis, which means we need a negative in front of the 1. X minus 5 to the third, okay? And then 3, we have a vertical compression by a factor of 1/2, which would just mean y equals -1, 2, like there's the 1/2, so -1 over 2 times x minus 5 to the third. And that is our final answer. Okay, moving on. The function f is given by the equation f of x equals 3x squared plus 5. Use this equation to answer the questions below. What is the domain and range of f of x? Okay, so since this is a parabola, we know that it's going to go somewhat like this. So it means it's going to go up forever and up forever on both sides. So our domain is -infinity to infinity. But as for our range, we know we normally start a parabola at 0, 0, but since we have a vertical shift up 5, we're actually starting at 0, 5. So our lowest point would be 5 and our highest would be positive infinity. Okay? Let the graph of G be created by the following transformations of f. Vertical dilation by a factor of 1/3 and a vertical dilation. So this is our A. Horizontal dilation by a factor of 10. This is in front of the x. And then a horizontal translation, right 6, and a vertical translation up 1/3. What is the equation of g of x in terms of f of x? So we know we're going to start our equation like this. G of x equals, and our a is 1/3, and then f of x. And then we know we have a vertical dilation of 10, so we have to do the reciprocal of that. 1/10, parenthesis, and then we do our translation right 6, which would in reality be minus 6, parenthesis, and then a vertical translation up 1/3. So this is our final equation. This question is saying, let the graph of h be created by the following transformations of f of x. A vertical shift down 10, a horizontal shift left 7, and a reflection across the x-axis. What are the domain and range of h of x? Okay, so h of x is created based off a reflection across the x-axis, which means there is a negative symbol in front of our function of f, and then x plus 7, and then minus 10. Okay, what is the domain and the range? We know our original domain was negative infinity to infinity, so our domain remains the same, because no matter how much you add to it, it would still remain negative, and no matter how much you add to the positive, it'll still be positive. Okay, and as for our range, we do -1 times y minus 10. So if we look back up, our original range was 5 to infinity. But now we have to multiply 5 by -1, which would be -5 minus 10, which would give us -15. But we also must not forget that our positive infinity has to be multiplied by -1, which makes it negative infinity minus 10, which is still negative. So we're actually starting from negative infinity, and the highest we'll go is -15. Okay, the absolute minimum of k of x occurs at the point -3, 15. The graph of k is created by a sequence of transformations of f. What transformations could apply to f to get the absolute minimum for k? Okay, so we know k of x, which would be -3, is equal to 15. And this minimum is through a horizontal translation, left 3, and a vertical translation, up 10. Using your answers from part D, write an equation for k of x in terms of f of x. Okay, so k of x is equal to f of x plus 3, because up here it went left 3, plus 10. And that is our final answer. Okay, moving on. Given f of x squared plus 3x minus 18, the function g is a multiplicative transformation of the function f that results in a vertical dilation of the graph of f by a factor of a equals -3. And we must write a function based on these descriptions. So, the function g of x is -3 f of x. But now we must solve. So we plug in the f of x equation. So in reality, we're plugging x squared plus 3x minus 18, which gives us -3x squared minus 9x plus 59. G of x equals, alright, oh, it actually equals 54. Oops. This is what it's giving. And then we know our domain, if we were to be asked for it, would be negative infinity to positive infinity due to our equation being a parabola. Okay, for our last one, given f of x equals 2x over x minus 3, the function g is an additive transformation of the function f that results in a vertical translation of the graph f by k equals 6. So g of x equals 2x over x minus 3 plus 6. And if we were to be asked for the domain here, it would be negative infinity. However, the reason it's not to positive infinity is because of this vertical asymptote here, which would stop us right at positive 3. So it's to 3 union 3 to infinity. And that's it for today. Thank you for joining me today. Have a good one.